This is a video on finding the surface area of a solid that's formed by revolving a curve about an axis. The question states, find the area of the surface formed by revolving the graph of y equals e to the x on the interval from 0 to 1 about the y-axis. So we first graph it, and when I do that, I get the curve y equals e to the x, and between 0 and 1 I've marked in red, and then I'm going to take a cross-section like so, and I'm going to take that cross-section and revolve it around the y-axis. If we reflect it across the y-axis, the other side will be a little cross-section like so. So to revolve it, or at least to show the revolved region, I'm going to take the bottom two endpoints, and I'm going to connect those with an oval, and I'm going to take the top two endpoints, and I'm going to connect those with an oval, as so. And what I get is a frustum. And the area of a frustum is 2 times pi times the radius times the length. And the radius is going to be the distance from the axis of rotation to the curve, and that's just the x-coordinate of that point, or x. The length, remember, we use the formula. The length is equal to the square root of 1 plus the square of the derivative. The derivative of e to the x is also e to the x. Square it, you get e to the 2x. And my length is the square root of 1 plus e to the 2x. Now that we know what the area is, I'm going to find the volume by integrating the area. So what I get is the area was 2 times pi, there's my 2 times pi, times our radius, and the radius has a variable, I put that inside the integrand, times the length, and there's our length. And I'm going to go from 0 to 1, because that's the problem. It states that we're supposed to go from 0 to 1. And I used a calculator to do this integral, and I got about 7.05. And that's the end of the problem.